Hi. Thank you. Hi, my name is Martin Havelka. I'm backend software engineer at Outreach, the amazing host of this amazing event, by the way. And today I would like to speak about something much more basic than the previous topic, back to the roots. So I would like to talk about defer and my, let's say, observations about this quite unique statement of the Go language. Okay. So today I will talk about some basic mechanics of the defer statement. I think this is something that probably most of you already know, but let's cover it up. Some recommended usages. Again, I believe that is something probably most of you are aware of, but let's again cover it up. And then I would like to go a little bit deeper to check how it do performance-wise, and also what can be a little bit tricky about defer and what to, avoid or let's say be aware of, so you don't do some kind of unpredictable code. So let's get on to it. So the basic mechanics are the defer statement. The first time when I saw it in the code, I was like, what is this? I didn't know, I had no clue, but within like 5 minutes or maybe even less, I was like, oh yeah, it's so clear, it's so obvious, what does it do? And that's, I think, the beauty of it. So what the defer does is that it runs a function or the code on the end of your block, of your function. This is amazing because you don't have to be worried about that. You don't have to kind of remember it on every return or on every possible escape point from your function that you need to do some kind of process, something. So you can just like register your defer function, and you can be sure, you have guarantees that this code will run on the end. You can have multiple defer statements in one function. They are ordered in the LIFO stack. So basically, the last in goes first. So if you have multiple ones, the last one goes first, and so on. And for this, I have like just like a small snippet just to show you how it works. This is very visible. Yeah, it is. So this is like very basic functions. You can see it's 3 iterations through the loop. And first we register the defer function, which prints out the current value of the step, and then just like very simple function that calculates like multiplied by 2 and again print it out. Let's just run it to see how the order works, just to be on the same page here. So here what you can see, the first what was printed out are the inners. So basically that's very much expected, right? So the first was printed out 0, 2, and 4 because that's the order how it goes. And then the defer functions were triggered, but as I stated before, in the opposite direction. So it's 4, 2, 0. Very clear. Okay. Another mechanic of the defer statement, it's usage of the named return values. This is something that it's in Go language, like that you can have unnamed or named return values. And actually with the named return values, you can kind of affect by the defer what the return values will be. That's the way, for example, if you are returning an error and in your defer function something goes wrong, something, I don't know, like closing database connection doesn't work, but you want to kind of, get the caller notify, you are able to affect this from the defer function. And then the last mechanics I would like to speak about is the evaluation of the function arguments. This is something that if you have the function there and that is registered by the defer, and this function has arguments, those arguments are actually evaluated at the moment when you are registering this deferred function, which is somehow can bring some weird scenarios, and because then the code is executed on the end. And I would like to focus on this area a little bit more into the detail on the end of the presentation, just to show you a few examples what can go like, I would say, unpredictably. Okay, so this is I think discovered the basic mechanics, and let's talk about the usages a little bit. The recommended usages, there are actually not that many of them. I think the basic ones are the cleaning up of the resources. As I mentioned here, for example, closing the database or closing the file. Of course, you can do like some procedures. I don't know if you will have some counter and you want to make sure that every time the counter is increased by 1 on the end of your function. Also very good usage. And then there is a very specific mechanism of panic and recovery in a Go application, and actually the defer is the only way how to elevate panic and recovery. You cannot do it without that. It's very useful. It's very useful. It allows you to kind of control your application even in a case that it got runtime error, or even like your own application can panic by your own code, and you are able to catch it and basically do something else than just crash and end up the application. Okay. So after when I, let's say, first encountered the defer, as I said, it was very easy to understand. And when I get more and more to know the defer, I was also interested about how it performs and like what are the other under the hood, let's say, mechanisms and code. So first, what I did when I was investigating, the defer function, I try to figure out what exactly is happening, like what the compiler gives us. And this is what I've got. Those two functions are mostly the same. The only difference is that here I'm doing the defer with the, here I'm doing the defer and here I'm not doing the defer. And as you can see, the compiler output is actually a little bit different, and there is definitely some overhead on the defer function. It's I definitely understand exactly each of those lines and what exactly it means and what does it do. But still, I think this is a good base to kind of understand that the defer, it's really having something more than done there, and from that I was like, okay, I really don't know exactly how this will impact the performance, but let's check that out. So I use just the basic benchmarking functionality of the Go language, and I tried it out. So let's check it out. First, we will run our function with defer, and as you can see, the performance is really good, like 2.5 nanoseconds per operation. I think this is really good performance. No problem with that. I don't see it as an issue. But let's see how it will do without the defer. It's very same functionality. Okay. So this is 0.3 nanoseconds per operation, which is obviously better, but we are still talking about nanoseconds here. So this is not something that we should definitely consider as a blocker. for standard usages. And so I would say the performance, even though the numbers are there, it's still really negligible, and only point where I would consider this is when I would be running some iteration with lot of iterations that could somehow affect my performance. Otherwise, really don't be worried about this. Don't use it wisely. Okay, so I think from the performance standpoint, this is covered, and let's check. In the previous section, I actually promised that I would like to also show you how the named arguments can bring some kind of, let's say, behavior that maybe you will not be able immediately recognize, and this is the part where I would like to also have your participation. So what I did here is I write very simple counter that has just 3 methods: increase, decrease, and count, which just prints out the current value. And let's see how this behaves in our tests. So this is the first use case. So let's start. We will just initiate the counter with 1000. Then we will increase its value by 100. Then we register the deferred function, which will print it out for us on the end. And then we decrease the counter by 600. So what do you think is going to be printed out? Okay, that's, wow. I have amazing audience here, so I'm not sure if I should continue, but let's try. So we have very similar code here with one slight difference, that the function we are deferring is now having the counter as argument, and it's actually passed to the function when the defer function is registered. Again, what do you think it's going to be? The value that is printed out. Oh my God. Such a good answers, no confusions here. 1100, you are right. Okay, time to close it up. Okay, let's try one more use case. Again, we have very similar code, and the only difference here is that now we are passing a pointer to this object. What do you think is going to be the printed value? 500. Correct. Okay, let's go further. So now we are actually just directly calling the counts. And in this case, we are calling 2 defers. So again, what do you think is going to be the printed values?
500 plus.
Yeah. Correct. Oh shit. I don't want to give you my password. No. My password is no. Okay, let's check this one out. Here, what I'm doing, the only difference from the previous use case is that we are having a pointer here. So what do you think the printed values are going to be?
500.
Yes. Wow, 100% accuracy so far. Amazing. But let's make it a little bit more, let's go farther. Here I created another counter object. The only difference from the previous one is actually that this receiver, it's not a pointer, so I'm creating the copies of the object when calling this. But I know this is not the best practice, but still it's possible to do. So let's try it out, how this will behave. So we have here this, actually is the exactly same code as we had. Okay, sorry, I will start from the end actually. All right, cool. Here. So let's start from the last use case. What do you think? Just to print it out. Okay, so the previous use case gave us 500, and with the exactly same code, just using this another counter. What do you think? What are the guesses? Hold on, let's try it out. 500 and 1,100. Okay, this time I've heard like not that many answers, so you either got bored or or you don't know. So this is because we are not having here the pointer to the object. Therefore, we are creating like the new instance of the object there all the time. So let's try this. Okay, so in this case, again, like before, the answer was 500 and 500, and now we will use this no pointer counter. What do you think the output is going to be? It's the last one. Let's try it out.
Oh, last in first time. Okay.
All right. So this is something that behaves differently, very much depending on how, you know, like do you have asterisks there or here, and it can get confusing. It can get somehow unpredictable. And I think in this case, I would really recommend you to try to stick with the Go basics, which is saying keep it simple. So don't try to invent some weird structures and stuff that will make it complicated. And just choose one of the approaches. I really recommend really the basic ones when you just have like the anonymous function or directly calling the function, and that's it. That would solve it for you, and you don't have to worry about this. If you see something like this in a review, code review, maybe just make a suggestion, you know, to make it simple, basically. All right. This is all I wanted to show you. I know that's much more basic than was the previous talk, but I was really kind of passionate about the defer and how it works when I got introduced for the Go language. So that's the reason I wanted to share it with you.